Phase H is where architecture stays alive after deployment. In this module, we'll see how operational feedback, business change, technology shifts, and security or AI lifecycle needs trigger-controlled updates, so a secure Azure-based enterprise AI platform remains fit for purpose. Up to this point, you've built the foundation. TOGAF concepts, target architectures, Azure AI solution patterns, security, governance, migration, and implementation oversight. Now the focus changes. Instead of asking how architecture is delivered, Phase H asks how it stays useful after deployment, as priorities, risks, technology, and business conditions continue to move. This is where architecture becomes a living practice, not a one-time design. Once a solution is deployed, the enterprise watches how it performs in real operations. Performance data, incidents, regulatory changes, business shifts, and AI model behavior can all signal that the architecture needs attention. Some changes are minor and can be handled through governance. Others are significant enough to trigger a new ADM cycle. The essential idea is the feedback loop. Operations inform requirements, requirements shape future architecture, and architecture stays aligned with strategy over time. Architecture rarely changes simply because someone wants a new design. It changes because a trigger makes the current architecture questionable. External triggers may include regulation, standards, contracts, or geopolitical requirements. Technology triggers include new AI capabilities, cloud platform changes, data growth, or services reaching end of life. Operational signals matter too, such as incidents, poor performance, reliability gaps, or recovery findings. Business change can be just as powerful. New products, acquisitions, user feedback, or changing customer expectations. Phase H turns these signals into governed architecture decisions. The first practical question is, what kind of change are we dealing with? Routine changes, such as a minor dashboard update, can usually move through normal operating procedures if they stay within approved guardrails. Incremental changes, like adding a new AI model or integration, need architecture review, updated artifacts, and controlled implementation. Major changes, such as a new regulation or business model shift, may reopen the ADM cycle. Classification is not based on size alone. Consider business impact, security exposure, data sensitivity, cost, compliance obligations, and AI risk before choosing the governance path. Once a change is raised, the architect traces its ripple effects. Start with the four core domains: business capabilities, data, applications, and technology. Then check the architecture artifacts behind them, including building blocks, standards, principles, constraints, and requirements. The key question is not, can we make the change? It is, what else must change for this to remain coherent and safe? In Azure environments, that includes services, identity boundaries, data classification, AI model behavior, security controls, and support processes. A good impact assessment turns a vague request into clear architectural consequences. Every change proposal in Phase H is a governance decision, not just an operational request. The proposal is classified, assessed for impact, and reviewed against architecture principles, standards, the target architecture, and business goals. The architecture board considers risk, urgency, and trade-offs. It may accept the change, accept it with conditions, defer it, reject it, or escalate it into a new ADM cycle. Traceability is what keeps this disciplined. Decisions should be documented and linked to requirements and repository artifacts, so agility in AI and cloud remains under architectural control. Operational readiness is the point where a design becomes a service the business can trust. Before go-live, teams need clear owners, support roles, escalation paths, and runbooks. They also need evidence that monitoring, logging, alerting, backup, recovery, incident response, and security controls actually work. Readiness is not just a one-time gate. It is validated against service-level objectives before launch, then rechecked after real production usage begins. For Azure AI solutions, the model should cover platform operations, data operations, security operations, and AI or ML ops, so models remain reliable, governed, and supportable. Observability turns raw operational signals into decisions. Start with the health indicators that matter: availability, latency, throughput, errors, cost, endpoint usage, and data pipeline status. Centralize logs from applications, APIs, Azure services, security tools, and AI components, so incidents can be traced end-to-end. Alerts should fire only when action is needed, using thresholds that reduce noise and fatigue. Service-level objectives then translate technical measures into business promises, helping teams respond before reliability issues become customer impact. Tools like Azure Monitor, Log Analytics, and Microsoft Sentinel support this loop. Runbooks turn architecture into operational muscle memory. They tell teams what to do when a data pipeline fails, an AI endpoint slows down, access breaks, or a security alert fires. The support model makes ownership explicit. Level 1 handles known issues, Level 2 investigates deeper patterns, and Level 3 brings in engineering, data, security, product, or architecture expertise. Incident response should move quickly from detection to triage, containment, recovery, and clear communication. The final step is learning. Every incident should update risks, controls, requirements, and future architecture decisions. Resilience in Phase H is an operating requirement, not just a document. Start by defining RTO and RPO from business criticality, how long a capability can be unavailable, and how much data loss is acceptable. Then confirm that backups cover more than databases. Include configurations, secrets, model artifacts, prompts, registries, monitoring data, and deployment pipelines. The key is proof. Run failover simulations, restoration drills, and regional recovery tests before an actual incident. When tests reveal gaps, feed those findings back into architecture decisions so continuity improves with every release. AI cannot be operated like a static application. The operating model must manage the full lifecycle of models, prompts, datasets, evaluations, endpoints, safety controls, and versions. MLOps provides that structure. Changes move from development into evaluation, approval, deployment, monitoring, and feedback for retraining. Version control is critical because even a small prompt or model change can alter behavior. Release management makes those changes reviewable, tested, approved, and traceable. The goal is disciplined change, improving AI capability while preserving reliability, safety, and accountability in production. Once an AI system is live, evaluation becomes a continuous control loop. Teams measure whether outputs are accurate, relevant, grounded, fair, robust, fast enough, and affordable. They also watch for drift, changes in data, user behavior, model performance, or output quality that push the system outside acceptable thresholds. Safety testing adds another layer, probing for harmful responses, prompt injection, data leakage, and policy violations. When thresholds are breached, the response is not guesswork. Teams retrain, redesign, adjust prompts, update policies, or pause use until risk returns to an acceptable level. Here is the Phase H loop in motion. A change starts as a request and passes through gates: architecture review, security checks, readiness testing, and AI safety validation. Once approved, the release is deployed across applications, data, models, and controls. Then operations show what really happened. Incidents, user feedback, performance metrics, and model evaluations become evidence. That evidence updates the architecture repository, preserves traceability, and may trigger another ADM cycle when the change is significant. Phase H closes the loop by keeping architecture alive after delivery. Change drivers must be detected early, operations must be observable and recoverable, and AI solutions need disciplined MLOps controls. You have now connected governance, readiness, security, and value realization. Next, you will apply the full ADM lifecycle in the capstone and architecture review board simulation.